Okay, I think you can start it.
Okay, so today we're going to solve LeetCode number 19 called remove the nth node from the end of the list. So we're given a standard linked list, aka the input head, and we want to remove the nth node from the end of the list and return its head. So as you can see here, n is 2, so we are going to traverse backwards and remove the second node. So that's 4, right? Pretty simple. If n is 1 here, there's only one node, then the output is going to be none. Okay, so this is a linked list question, obviously, so there are many ways we can do this, but the standard way to do it is to, first of all, check the base case. If the linked list doesn't have more than 2, actually, we don't have to do that because n is a constraint here. It could be 0, so, okay. So let's just create a dummy node first of all. And then what we want to do is we want to have 2 pointers. We want to have one starting from the previous dummy node and the right pointer here. And what we want to do is make the gap between the left and the right nodes exactly 2 pointers in terms of distance, because n is 2 here, and exactly n pointers. So for example, left is starting at dummy, right is starting at 1, and so we're going to move right forward by 2 because n is 2. So left is, by the end, left is still going to be on dummy, right is going to be on 3. So you have 2 nodes in between them, 1 and 2, 2 length nodes. After we do that, we are going to traverse both, we're going to increment both left and right pointers until right goes out of bounds. So right's 3, and we're going to say right's not none, so go to 4, right's not none, go to 5, right is none. So at that point, we are going to stop, and we are actually going to, the previous node of that would be the nth node. So by the time we get to none, by the time right gets to none, left node will be on 3, and right node will be on none. And at this point, all we have to do is say left.next equals to 5, because we want to cut off this 4th node by setting the previous node to the next node. Does that make sense?
Yeah, I think yes, makes sense.
And then after that, what we want to do is, well, we have this fragmented linked list. Now we just have to, we can actually just return the head of the linked list, and that's it. So the key thing to notice here is make the distance between the left and right pointers exactly n nodes. Okay, cool. So we can set 2 pointers, one to dummy and one to head. And we can say while fast is not none and n is bigger than 0, then fast equals fast.next, n minus equal to 1. Right? And then by this time, let's just print fast.value to make sure we're doing this correctly. Okay, so no non-type attribute. Okay. So fast.next or fast, let's see, fast equals fast.next. Because we're on the head, we have 1, 2 times. That's it. So n is bigger than 0. Fast is fast.next. So fast is 2. And n is 1. Fast is still not none. So fast goes to 3. N is 0. 0 is not bigger than 0. So fast should be on 3. But I don't know why this is. Maybe there's some kind of a edge case in there that doesn't allow it. But well. And now, as we said, now we have to move both pointers. So while fast, because we already have the distance, so we're just going to move them both in parallel until fast reaches the end of the linked list. So while fast is not none, we're going to do slow equals slow.next and fast equals fast.next. And at the end of this, again, slow's on 3, fast is on none now. And so what we're going to do is say slow's on 3, right? So we're going to say slow.next equals slow.next.next. And then I think we should say return dummy.next because that's a new head of the linked list. I don't think we have to join this 5 back to the 1 because we're just going in one direction. This might have some bugs, but we'll run it. Okay. Well, fast and fast up next. Okay, so slow is on the dummy. So, dummy doesn't have a next value, right? So let's see. Dummy.next equals head. Maybe we can do that, or we can join it correctly to the link the dummy to the actual head. Okay, a little bit better now. And
Wow. Okay.
there we go. So again, it's all just about getting this correct and making sure you're not on the none node. You have to make sure you connect the dummy to the actual input head, and then you just return the head because that's stored at the beginning as not modified, right? So
what about the time complexity?
is O(n) because we're only iterating through this linked list once, and space complexity is O(1) because we're not using any extra space.
Okay, sound good. Yeah.
So just remember, keep the distance between left and right pointers exactly n nodes.
Okay. Yeah, it's good.